Here we are presented with problem 6.11. The problem states that two concentrated loads are placed symmetrically on the simply supported beam. We are to determine the expression for the maximum displacement of the beam and also calculate the maximum displacement and maximum bending moment for a W14/26 section using the following data. A is 6 feet, L is 20 feet, P is 6,000 pounds, and E is 29 times 10 to the 6 psi. First, gonna write the givens. Given A is equals to 6 feet, L is 20 feet, P is equals to 6,000 pounds, and E is equals to 29 times 10 to the 6 psi. Now for the free body diagram, the problem states that two concentrated loads are placed symmetrically on a simply supported beam. So let's draw a simply supported beam. The total length is 20 feet. And from each supports, distance is 6 feet of each load. So this is 6,000 and this is also 6,000. By means of symmetry, the reaction of A, this is point A, and B. The reactions from point A is equals to the reaction of B and is equals to the load P. And also because of symmetry, the maximum deflection occurs right in the middle, like right here. Now, using the conjugate beam method or direct integration of the elastic curve equation, we can determine that the maximum deflection formula is equals to P times A multiplied to 3L squared minus 4A squared all over 24 EI, and the value of I according to steel tables. What was it again? 14/26 section, the I, or the moment of inertia, is equals to 245 inches to the fourth. Now substituting everything, the maximum displacement is equals to 6,000 pounds times 6 feet, and converting it into inches, 12 inches into 1 foot. Multiplied by 3 times L is 20 feet, converting into inches, this is 12 inches into a foot, square minus 4 multiplied by A is 6 feet Also converting it into inches. 12 inches into a foot, squared bracket, and all over 24 times the value of E is 29 times 10 to the 6. 29 times 10 to the 6 pound per square inches times the value of I, which is this 245 inches to the fourth. Now solving this gives us the value of maximum displacement is equals to 0.3852 430,683. Now for the unit analysis, just have to cancel this, the feet, also this one. This just becomes 2. This also becomes 2. This is just inch. And then the pounds are cancelled. And then this is inches multiplied by inches squared is inches to the 3. And then the remaining becomes inches cubed over inches squared. Now just cancel this and to this, the remaining is inches. So the force exerted is downward. So this is the maximum bending motion. So this is the maximum displacement, and for letter B, the maximum bending moment. From the left. So let's just try this. This is A. £6,000, and the length is 6 feet. So the maximum bending moment is simply just the load times the distance from the support. So it's just M max is equals to 6,000 pounds times 6 feet, or you can just convert it into inches, 12 inches to a foot. The value of M max is equals to 36,000 pound foot, or 432,000 pound inches, whichever you prefer.